Okay, so I am going to solve this problem. So we've got x prime of t plus 3x. Okay, that should be 3x of t, I guess, to keep things consistent, equals t plus e to the minus t. Okay, and I'm going to do this in the way that I like to do it, which is to first find a solution to the corresponding homogeneous equation. So this is x plus 3x is equal to 0, or x prime is equal to minus 3x. And then we know that solutions to this equation are going to be x of t is equal to some constant times e to the minus 3t. I don't know how to make that go away. Okay, and again, so you can, how did I come up with that? Well, I'm going to go through kind of a general procedure for doing that, but really I would like it if you could just know that if it's x prime equals minus 3x, then this is going to be the general solution. Okay, but if you didn't know that, how could you do this? And we'll see this more on the second and third problems. But I'm going to rewrite this equation as x prime over x is equal to minus 3. By the chain rule, the left-hand side is the derivative of the natural log of x. And again, it's with respect to t. This is equal to minus 3. And so if I integrate both sides with respect to t, because this derivative is with respect to t, remember t is the independent variable, then this tells me log of x of t is equal to minus 3t plus some constant c. And then if I raise both sides to the power of e, what I get is x of t is equal to e to the minus 3t plus c. But I can just write this as a times e to the minus 3t, where a is equal to e to the power of c. Okay, so I'm going to erase all of that. So that's sort of the general setup for solving the homogeneous equation. Okay, now I need to find a particular solution to the non-homogeneous equation. So that was the general solution to the corresponding homogeneous equation. Now I need to find a particular solution to the non-homogeneous equation, and when I add that to the homogeneous equation, or the solution to the homogeneous equation, that's going to give me the general solution to the non-homogeneous equation. So I just added an h there, a subscript, letting us know that that is the solution to the corresponding homogeneous equation. Okay, now for the non-homogeneous equation, there's depending on what the problem is, there's different ways to do this. But for this problem, I'm going to look for a particular solution in the form x of t, which is an unknown function, times xh of t, where xh of t is the corresponding homogeneous solution. And we just need one of them, so I'm going to take a is equal to 1. So this is x of t times e to the minus 3t. Okay, now the computation that I'm about to do, you don't have to do every single time. In fact, don't do it every single time once you kind of understand what's going on here. But when I take this xp of t and plug it into the equation, this is what I'm going to get. So I'm just going to write it. I'm not going to use the fact that that xh of t is equal to e to the minus 3t. Just look at this. So x of t times xh of t prime plus 3x of t. By the product rule, this is equal to x prime xh plus x xh prime plus, I messed this up. This is x of t, xh of t. Okay, so it's that plus 3 x of t, xh of t. Okay, now what's going to happen? Well, this right here, I can factor out an x, and so this is x prime xh plus xh prime plus 3xh. Okay, now this is just the corresponding homogeneous equation, so that's equal to 0, and so this is just equal to x prime times xh, and we're going to set this equal to the non-homogeneous part, which is t plus e to the minus t. Okay, so I'm going to erase all that work. Okay, so the idea then is that when you have an equation, that is written in the form that I have it, sorry, it's taking me longer to erase this than I thought it would. Okay, when you have an equation written in the way that I have it, then a solution to then to find a particular solution, you just want to solve x of t prime times xh of t is equal to the non-homogeneous part. Okay, and this only works if the coefficient on x prime is 1. Okay, if it's not 1, the same idea works. It's just going to be a little more complicated. There's going to be an a of t there. Anyways, I don't, one thing that I don't want to do is say, in this case, you do this. 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 That is just a horrible way. It's boring to teach. It's boring to learn. I want to give you the general things. And then as you do the problems, you'll kind of work out and see like, okay, so for this specific case, then I can do this shortcut. And it's just way better if you learn your own shortcuts that way. I'll give you some things, but most of the time for stuff like this, I'm not going to go and say for an equation of this form, do that. An equation of this form, do that. At least not as granular as some people might do. So anyways, what we end up with for the equation for the particular solution, we end up with e to the minus 3t times x prime of t is equal to t plus e to the minus t. Or in other words, x prime of t is equal to te to the 3t plus e to the 2t. Okay, and so now I want to just integrate both of these. Okay, so I want to integrate both sides. So x of t is going to be the antiderivative of te to the 3t plus e to the 2t. And I'm just going to add the constant now so I make sure that I don't forget it. Okay, so this is going to be 1/2 e to the 2t. That's the antiderivative of e to the t. And now I need to do this integral, the te to the 3t. Okay, well, this is going to be integration by parts. Okay, and so u is going to be equal to t. dv is e to the 3t dt. So this means du is equal to dt, and v is equal to 1/3 e to the t. Okay, so this is going to be u times v. So t e to the t over 3 minus the integral of v du. So v is 1/3. So this is going to be minus the integral of e to the t over 3 dt. Okay, and this is now 1/2 e to the t plus te to the t over 3 minus the antiderivative. I just realized there should be a 3 there, and so there should be a 3 there. This is going to be minus e to the 3t over 9. And I think there should be, I forgot the 3 there as well. Yeah. Okay, sorry about that. Okay, all right, so this then is what we have. And so there should be a 3 there. I think I forgot the 3 everywhere, didn't I? Well, I didn't forget the 3 there. That should be a 2. Okay. So now this is x of t, and so xp of t is just going to be this times the corresponding homogeneous solution, which is e to the minus 3t. So this, I'm just going to multiply through by e to the minus 3t, and this is going to give me 1/2 e to the minus t plus t over 3 minus 1 over 9. Okay, and the general solution is going to be the general solution. I'm just going to try to keep it all on the same page here. The general solution then, except I'm gonna make this. I'm gonna write this a little higher up so I have enough room to write down here in the margin. Okay, and so what this tells us is that the particular solution then, again, I'm just going to multiply this whole thing by the homogeneous solution. So this is 1/2 e to the minus t plus t over 3 minus 1 over 9. I did the same thing. I'm not giving myself enough room. Okay, one more time. So this will be, again, I'm going to multiply everything by e to the minus 3t. So this is 1/2 e to the minus t plus t over 3 minus 1 over 9. Okay, and then overall, the general solution to the non-homogeneous equation is going to be x of t is equal to a e to the minus 3t plus 1/2 e to the minus t plus t over 3 minus 1 over 9. Okay, and so that is the solution to this differential equation.